Hello everyone, my name is Andrew and today I will show you one of the most interesting concepts in Python. How to predict the future with Python. Let's start. So how can you predict future in general? There are lots of ways and some of them work, some of them do not work, but the main way to predict the future is to look in the past. So let's say that something happened in the past repeatedly. Like let's say if we mix some compound with another compound, the compound that we have is gonna blow up. So if we know that that happens in 99% of the cases, then we can predict the future by saying that, okay, if we mix this and this, it's gonna blow up, or something like that. So we can use past data to predict the future. And analysis, math, data science can be used as well, so it can be used all together in order to predict the future. And people do that all the time. So if you want to predict how your ad campaign is gonna work out, you need past data, or you need to run some sort of tests. So you need to gather some data. But we're not going to talk about this today because that's a very, very, very big topic. It's analysis, data science, all that stuff. So if you want to learn how to really predict the future, go learn about all that, and I'll see you here after 1 or maybe 2 years. However, there is another way of predicting the future in Python. It's not really predicting. You can still do some very, very, very bad stuff with it, but and very, very good stuff with it, so you can really predict the future. But it's a little bit different. So what is that? That is random. And what do I mean by random? If you worked with Python and if you worked with random, you probably heard about a concept called pseudo-random. So random library in Python is pseudo-random. What does it even mean? If I say print random.randInteger, so get me a random integer from 0 to 10, and if I say it 4 times, it's going to give me 4 random integers. For example, 2, 5, 6, 2. If I run it again, it's going to give me separate integers. So those are going to be different. They vary when I run my programs. And we can say, okay, it's random, but it's really not. It's pseudo-random. So what does it mean? That means that we can predict all the numbers that come out of random if we know one thing. That thing is called seed. So there is an algorithm. Well, there are lots of algorithms for pseudo-random, but the one in Python is called Mersenne whirl or something like that. So it's called Mersenne. And that algorithm uses a value, so any kind of value, to build up algebra, mathematic formulas, and give us random values. So basically, if you know the seed is the starting value of your algorithm. If you know the seed, if you know the starting value, the initial condition, then you can predict all the numbers that are going to come out. Let's say random.seed is 0. So I'm saying, okay, change my initial value to 0. If I do that, look what's going to happen. 6604. So those are the numbers. What's going to happen if I run it again? The numbers are going to be the same. And it doesn't matter how many times I run them, because that's just math. Those are mathematical formulas. There is nothing, no magic. And I'm saying that the value, the initial condition to that function, to that mathematical function is 0. If my initial condition does not change, my numbers are not going to change. It's the same as using a function in math. So if you don't change your x, y is not going to change. If I change random.seed to 1, then it's going to be different. But if I run it again, it's going to be the same. So basically, what do we have? Random seed is some sort of value that we use in order to build up our algorithms. However, when I comment out my random seed, so I don't change it by default, my values seem to be different, and they are different. How does it work? What's the value that goes up and up and up, or what's the value that changes every time I run my program? What is that value that can be used in random.seed? Because if I put different seeds, like 10, I get different values. But what I want to do with my random is I want to do it automatically. I do not want to change that random seed every time I run my program. So what's the value that we can put in random.seed to make that algorithm random, or pseudo-random, but make it seem random? What can we do? What's that one value that goes up and up and up? And I'm pretty sure you already know the answer. It's time. So in computers, time is an integer. So it's not an integer, but it's some numerical value. It depends, and I really don't know how that works in the computer itself, but it's some numerical value that goes up and up and up each nanosecond, each millisecond, each second, each hour, and so on. So basically, what we have is if I import time module in Python, I can say time.time ns. ns means nanoseconds, so we don't get any float values, we just get an integer. Let's comment it out and let's see. If I run my code, I can see that that's a very, very big value. But what's the most important thing is that if I run it again, the value is going to change. I did not change the function, but I waited for like 3 seconds between my program runs. So the value changed automatically. Because what we do with that function is we just get the time. Yeah, you can even see return current time in nanoseconds. And since the epoch is the starting point of our time, we can say like that. So that's the beginning of that computer's time. And yeah, that's how it works. So what we can do is just copy time_ns and then put it in random.seed right here. If I run it again, and of course close the parentheses, and if I run it again, 0588 66710, we get the result that we wanted. So I spent 6 minutes talking about all that, but that's really, really, really important for you to understand how all the things that I'm going to talk about in the future or in that video, well, later, are going to work. So basically, by default, C, so Python works in C language, and C language does the same thing. Random.seed is default, random.seed defaults to time. So the default value of random seed is time. That's it. Maybe the function of time is different because we have monotonic ns, we have time. So the function of time is different. But the most important thing is that we use time to get our random values. So what does it mean? That means that if there is a point in time, let's say I have datetime module here, and let's say datetime.now. So we get our current date. I'm going to run my program, and you see that's my current date. So let's say I want to predict what's going to happen with my random values in like 3 days. What are going to be my random values in 3 days from now? What can I do? So datetime.datetime_now gives me my current time. And let's do from datetime import time delta and date time. So what can I do? I can use a thing called time delta to add some I don't even know how to say, some time to my date time. So basically what's going to be datetime.now, so my current moment, plus time delta, and let's say days 2. What's going to happen in 2 days from now? And let's say future. I'm just going to call it future. So future or future time. And what I can do with future time, so let me just print it for a moment. So you can see that it added 2 days to my date. So now it's 11th of February, but that's 13th of February. So basically I added 2 days. However, what we can do is also get a thing called timestamp. And timestamp is basically this date in a time. As you can see, it does not use nanoseconds, so these are nanoseconds. That's just a float. We can easily convert it to an integer, but I don't really want to do it. So basically, we added 2 days to my date time, to my current moment. And then I print future.timestamp to get the time, or get nanoseconds since the epoch, so get my time for that future time, so for that variable. What can we do now? We can just copy this and put it in random.seed. And now look at the result. I run it, and result. Result changes because my time changes. But basically, what does it mean? Yeah, result changes because that initial date time changes. Yeah, I run my program. My date changes. So yeah, that's fine. But the thing is that right now I'm saying that's my future date. That's my future timestamp. What are going to be the values for that future timestamp if we run those 4 functions? So what are going to be the values of those 4 randint calls in the future from 2 days from now on? What's going to happen? It's going to give me values. So let's say 4300. So, okay, so what? We have those values. What's going to happen? The following thing. If we are able to get in that exact moment in the future, then the values that we're going to get are 4300. And you may say, okay, but that's not really predicting the future. It actually is, because there are lots of security vulnerabilities related to that. There are lots of casinos lost a lot of money because of this, because they use pseudo-random and people were able to get the seed. That's the easiest way to predict time in Python. However, I want to show you another thing, which is a little bit more complicated, and that's just a theory. That's a theory of my own, so I invented it, but me, you, people in the future, so anyone is not going to be able to replicate it. It's just a theory that it can be true, but it's never going to be true, trust me. So what's my theory? Let's say that we have some values that we want we have some values and we want them to happen in the future. So let's say that we have values like, values like 1, 2, 3, 4, or 1, 2, 10, 6, I don't know. So those are some values that we want them to happen in the future. So what can it be? A price of a stock. It goes from 1 to 2 to 10, then to 6. It can be our coordinates in the future. So I go one step forward, 2 steps to the right, 10 steps, I don't know, to the left, and 6 steps back. So these are the actions and we want them to happen in the future. Because basically in our real world, you can convert anything to numbers. You have 3 axes, like X, Y, and Z. You have temperature, again, numbers. You have anything is a number. Even my speech. So my speech, I'm saying that, you're listening to that. All those are the waves that are coming from my mouth and into the microphone, and so on and so on and so on. So we can convert all the things to numbers. So what does it mean? If we have those things in numbers, we can get an array. Let's say 1, 2, 10, 6. So those are some numbers that we want them to happen in the future. So future values. Future values. We want those numbers to happen in the future. Once again, coordinates, stock price, whatever you want them to be. And then what we can say? We can say, okay, which seed is going to be true for these numbers? Basically, I'm going to say something like that. While true, and let's start from 0, but we can actually start from time.timeNS. Let's start from time.timeNS. So let's say I start from my current moment, right? And my seed is my current moment. And then I say, okay, random.seed is my seed. And then what I do is I just generate my guess. So I generate 4 random numbers from 0 to 10. Like this, like this, like this. So I generate 4 random values. And then if I say if guess is equal to my future values, print my seed, and then break. And let's see what's going to happen. I run my program, and if everything's correct, oh yeah, I forgot to do one thing. We need to also change the seed. So seed plus equals to 1. Yeah, because we need to update the seed. So what's going to happen? That moment in the future, and we can convert it to a date time. So let's say print.datetime from timestamp. I'm going to put it here, and let's remove some values because timestamp accepts, let's remove some more values. It's just like milliseconds. Okay, let's remove some more values. Okay, so those values, 1, 2, 10, 6, are going to happen at that exact moment. We know that. So we know that, okay, those values are going to happen at that exact moment. And if I want those values to be true, just mathematically for now, if I want them to be true, I need to run my code, my random, at this specific time. Okay, so now we know that we can predict values in the future, not just get the values from the past and calculate the seed. However, here's the interesting thing. If I know that my values are going to be true in that specific moment in the future, then what I can do is increase the amount of values. So let's say that we get all the historical events from our planet. So we get all the historical events, or we get all the important events from your life. We use them as numbers, so we convert them to numbers. Let's say your happiness levels, your your bank account at that moment, where were you, your coordinates, all that stuff. We convert them to numbers, so we get a lot of data, like millions and millions and millions of data of numbers, and convert them to a big array or a big database. And what we can say, okay, if we know the seed that's going to be here, so if we know the seed that's going to generate all these values, then we can use this seed to predict what's going to happen in the future. So basically, if you have a lot of values and the seed that you're using, so the seed that we get in that while true, is the correct one, then we can use it in order to predict the future values. However, we really cannot. So what I'm saying is that if you know the seed that can generate all of the events in your life, so all of the events that happen to you are generated with that seed, because you generate the same numbers. So all the events are numbers, so you convert them to numbers, like again, your happiness levels, your coordinates, anything that you want. And then you use that seed from the random to find the seed that is used in order to replicate all the events. What you can do next is continue the generation. So if you have, let's say, 1, 2, 10, 6, what you can do next is continue the generation. And if you can interpret the numbers that are going to come out of your seed after that generation, so after your continuous generation, then you can predict the future, because all the events in your life were generated with that seed. So that seed is the correct one. And you know that, okay, my life, all the events in my life correspond to the events that come out of that random seed. If you know that, then in theory, you can generate more and more and more numbers to find out what's going to happen in the future. And that's pretty cool. However, of course, you cannot do that. And why is that? Because if I remove break, let's see what's going to happen. This is what's going to happen. All these things are different seeds. So what does that mean? That means that even if we are able to get all the events down to the minute detail into a seed, so into future values, and then find a seed that corresponds to those future values, then there are going to be infinitely more seeds that correspond to the same values. So what does it mean? That means that seeds, so 99% of the seeds, even like 100% of the seeds are incorrect. There's only one seed that can predict the future, but you will never be able to find it. Why is that? Because each minute detail, let's say you didn't sleep enough, you failed your exam, then you failed your exam, you were sad, you failed your exam, something happened, and all that stuff. So each minimal detail affects your life a lot. If you have millions of numbers, the amount of seeds does not change. So, because seeds are infinite, a seed is a number or any kind of value. Seed can be A, B, C, D, E. But since we use time, it's a number. So seed is a number, and there are infinitely many numbers. So in theory, what you can do is you can find the seed, even with this program. If you can account for all the values, so all the events in your life and put them in future values, then you can theoretically find the seed that's going to solve your life. And you're going to see the future with that, because you're going to generate random numbers and interpret them in a kind of way that allows you to see what's going to happen. But the chance of you doing so is zero. It's basically you're not going to be able to find it. And even if you find a seed that's going to be true for some of the events, so let's say you find a seed that can predict your tomorrow or can predict your next week, what's going to happen after that week? Because there are millions of seeds that can generate the same values. So let's say the seed generates the same million values, and then million and first value is different. What's going to happen with that? We don't know. So that's why you're never going to be able to find that seed, and that's why you should just go to data science and analytics if you want to really predict the future. But in theory, if you do that, you can predict everything. But you'll never know, because it can change abruptly, because there are millions of seeds that do the same thing, generate the same values, and so on and so on and so on. My name is Andrew. Thank you for watching, and bye-bye.